Hello everybody. Today we will be talking about solving right triangles. To solve a right triangle, it means a couple of things. First thing, to solve a right triangle, it means to find all the sides. We need to find the lengths of both legs and the hypotenuse. It also means to find all angles, all the angle measures. We already know one angle is 90 degrees, the right angle. We are going to find the other two acute angles right there and there. To find the sides and to find the angles, we are going to apply what we've been practicing with our trigonomic functions. We will label the HOA, hypotenuse, opposite, and adjacent sides. We will use SOHCAHTOA to find sides. We will use the inverse of SOHCAHTOA, the arc sine, arc cosine, and arc tangent to find the missing angles. All the stuff we've been doing just wrapped into one problem. So, to find sides, to find the sides of a right triangle, you have to look at it and see what you know about it. If you happen to know one side of the right triangle and one acute angle, then we're going to use trig. We are going to use our trig ratios, SOHCAHTOA, to find another side. After you find the second side, that's when you know two sides, or if you start the problem and you happen to know two sides of the right triangle, then we are going to go into our memory banks and use what we know. We are going to use the Pythagorean theorem. Pythagorean theorem, a squared plus b squared plus equals c squared. Apply what we know, and that's how we are going to find the third side. Once again, to find the sides, you're either going to use your trig ratios and SOHCAHTOA to find one, or if you happen to know two sides, then we're going to use the Pythagorean theorem. A squared plus b squared equals c squared to find the third side. Sides are easy, we can do it. To find angles. To find missing angles, we are going to use our inverse trig. If you know two sides of a right triangle, then we can use inverse trig to find the angle. Then we can use the complement, we're going to subtract from 90 degrees, to find the third angle. Now that we have our notes written down, we can move on and start working on some examples. This will be example 1 right here. If we examine example 1 to start with, we'll notice what we know and what we need to find out. In example 1, I notice that it's a right triangle, and we are given one angle 63 degrees. We don't know the other angle, it's labeled theta. We also know one of the legs is 15. We don't know the missing side x. We don't know the missing side y. So to solve this right triangle, we are going to have to solve for x, y, and theta. Let's solve for the missing sides first. Let's solve for x and y. To solve for x or y, to solve for those sides, I'm going to use my trig functions. First, I'm going to notice and ID that I know this angle is 63 degrees. This angle, 63 degrees, is what I'm going to use to label and go all the way across and see that 15 is my opposite side. "15 is our opposite side. Use our right angle to show that x is the hypotenuse. It's going to be the longest side, and that means that y is our adjacent side over here. First, I'm going to solve for x, the hypotenuse. I could solve for y first, the adjacent side. It doesn't matter which one you do first. I want to solve for the hypotenuse. Using SOHCAHTOA, the hypotenuse shows up in SO and it shows up in KA. We know 15 is the opposite side, SO and TO. That tells me that this is going to be a sine problem. Let's set up our trig equation. The sine of 63 degrees is equal to the opposite side over the hypotenuse, 15 over x. Let's solve for x. Since x is on the bottom of the fraction, it tells me that it's going to, after we cross multiply, turn out to be a division problem. X equals 15 divided by the sine of 63. From here, let's use our calculator. 15 divided by the sine of 63 degrees. 63 degrees equals 16.8348936. Let's round that answer to the nearest tenth, so we know that x is equal to 16.8. X equals 16.8. Sorry about that. Now that I've solved for x, I can also solve for y. We could use SOHCAHTOA again and set up another trig equation and solve for y. Or we can use the Pythagorean theorem. We should remember that the Pythagorean theorem is a squared plus b squared equals c squared. A and B are the legs, C is the hypotenuse. So x that we just worked on is the hypotenuse C. I'm going to call the adjacent side A, the opposite side we'll call B. Now that I know what now that I know what the opposite side B is 15, the hypotenuse is 16.8, that's C, I can plug them into my Pythagorean theorem and solve for the missing side. Y squared plus 15 squared equals 16.8 squared. Move that up a little bit. Let's do some math. Y plus 15 squared is 225 equals 16.8 squared. 16.8 squared, that is 282.24. I'm going to subtract that. We're going to subtract to solve for y squared, 225 on both sides of the equation. We're going to get that y squared equals 57.24. Now that we have solved for y squared, we can square root both sides and solve for y. Use our calculator for that. 57.24. Need to put the square root in front of that. Try that again. Square root of 57.24 equals 7.565712128. Let's round that to the nearest tenth. Our final answer for y is going to be 7.6. So, we use Pythagorean theorem to solve for one missing side y. We use trigonometry and SOHCAHTOA to find for the first missing side x. Y is 7.6. Let's write that up there. The only thing we have left to solve for is theta, our missing angle. Well, thankfully we know that the two acute angles, 63 and theta in this case, are complementary. That means they make 90 degrees. 90 degrees, subtract 63, the